Hello everyone, welcome back to another session of Verilog coding with me. So let's get started. So today we will be receiving about modules and vectors. So here is our problem statement. This is an extension of module shape instead of module ports being only. So we have to interface this in the Verilog code. So these are the different submodules, my TFF8, and this is the mux we have to make. So let's get started. So here is the description, you can read it. So as we have discussed earlier about the how to instantiate the modules. So let's first we have to write the module name IDFF8. So first we have to declare the wires for the in between results. So here they have given us the wire should be of 8 bit. So the output of the first one is x1, output of the second is x2, and the output of the third is x3. So we will start writing output. This is the module. So here they are given first is input, second is input, and third is output. So we have to write the same input and the output of the first one is x1. Similarly for other modules, input is our clock. Then for this one, the input D is the output of the first one. X1, the output. Similarly for third one, now X. So here the interesting part is that we have to build our mux on our own. So let's see how we can build the mux. So here they have given us the hint always add start block. So we will use that. Begin. After every always block we have to start with begin. So again what we have provided is so here they have given us another hint. One possible way to write one is inside an always block with a case statement. So we will use the case statement. Case. Inside case we will our case is selected for select line. This. So 0 if it is 0 Q is our output. So for the first one, if it is 0, then output is RD. Similarly, select 1, 2, the output is our X1, the intermediate result. So for 2, Q equal to, for the third one, it is output X2. Similarly, for third one, Q equal to X4. So after starting the case, we have to end the case. For that, we need to write end case. And as we have begun the always block, it should also end. So we have to write end. Now let's submit. So as you can see, compilation process has been started. Okay, so we have forgot to declare another wire. Okay, okay. That was typo error. So as you can see, compilation process is started. There are no errors. And as you can see the timing diagram, it's all correct. And the statistics is. So next time we will see about the other two, module add and module f add. So that's all for today.